we have a word problem. It says, at a constant speed, the distance traveled varies directly as the time. The distance traveled varies directly as the time. And then it says, suppose a runner covers 1 mile in 7 minutes. At this rate, what distance will be covered in 30 minutes? So we're talking about distance traveled varies directly as the time. So I'm just going to, distance traveled varies directly as the time. That's going to be our formula. So we have to decide, distance traveled, I'm going to let that equal D. So D equals distance traveled. And it looks like distance traveled is going to be in miles. So I'm going to put miles in parentheses. And it's going to vary directly as the time. So we're going to let T equal time. And time is going to be in minutes. So those are the variables that I'm choosing to use. So distance traveled varies, so D equals directly as the time, so K times T. So if we were doing our steps, that would be our first step. Now it says, suppose a runner covers 1 mile in 7 minutes. So I'm going to use some highlighters here. Distance traveled, that's miles. That's going to be 1 mile. Time is 7 minutes, right? So when I write this down, I'm going to say, okay, well, they're giving me a distance of 1 mile equals K times 7. I'm going to divide both sides by 7, and I get K equals 1 over 7. So my specific formula is D equals, I'm going to go back up here to step 1, D equals 1/7 times time. Now I'm going to use that formula, I'm going to use that specific formula to say at this rate, what distance will be covered in 30 minutes. So D is what we're looking for. That's going to equal 1/7 times 30. So D equals 30 over 7, which is equal to 4 2/7 miles. So this is an exact answer. It's a beautiful answer, 4 2/7 miles. You could also divide 30 by 7, and you can get 4.286 miles. So either one of those answers is going to work. 4 2/7 is a beautiful answer, but 4.286, some people like decimals, and that's fine too. Okay, let's do another word problem. Suppose that the time needed to do a job varies inversely with the number of people working on the job. Suppose that the time needed to do a job varies inversely with the number of people working on the job. If it takes 8 hours for 3 people to load a moving van, how long would it take 4 people? So let's think about this. Maybe even press pause and see if you can define what your variables are going to be, and maybe even setting this up and possibly even solving it. Meanwhile, I'm going to work it out. So the time needed to do a job varies inversely with the number of people working on the job. So T is going to equal time needed, and that time is going to be in hours. And it's going to vary inversely with the number of people. So N is going to equal the number of people working the job. And I don't think we need to put anything in parentheses because we said that it was people. So I think we're good there. Now my first step, time varies inversely with the number of people. Step 2, it's going to take 8 hours for 3 people to load a moving van. So 8 goes in for time. 3 people, that's going to go in for n. And k is going to equal 24. So our specific formula for this problem, t equals 24 over n. Now we can see, okay, well, if we want to use 4 people, if we want to use 5 people, if we want to only take up 12 hours, we can put different values in for either the time or the number of people so that we can figure out what it is that we need to make this job happen. So how long would it take for 4 people? So t is equal to 24 divided by 4, which is equal to 6, and time is in hours. So if you have 4 people working, it's only going to take 6 hours to load the moving van. So makes sense. The more people you have working, the less time it's going to take to finish that given job. So hopefully you're feeling a little confident there with some of these word problems. They do get a little stickier because we start talking about things like electrical current and amps and resistance and light and the square of the distance. So these are the 2 last word problems that are going to be coming up in the next video. They're really good ones to make sure that you're being detailed on, and you're likely going to see these somewhere else along the way. So I'm going to come back and do these 2 word problems in the next video.